everyone, my name is Jess Larson, and I am meshIQ's Events Manager. I would like to welcome everyone attending as we really appreciate you taking the time to join us. In case you don't know, we present monthly TechTalk webinars on different middleware technology topics. At the end of this presentation, I will include links to watch past TechTalks on demand if you missed any of the previous webinars. Today's topic is Unraveling the Security Challenges of Apache Kafka. Feel free to send any questions you have throughout the presentation in the Q&A box for the Q&A portion at the end of the webinar. Before we start, I would like to introduce our speaker today. Albert Mavashev is meshIQ CTO living in New York. As meshIQ CTO, Albert turns ideas into real-world solutions. Albert's work specialties are application performance, performance measurement and practices, streaming analytics at scale, clustered computing, big fast data, transaction analytics, complex event processing, middleware, IT service management, ops, and DevOps. I will now pass it over to Albert to get started.
Thank you, Jessica, for the intro. Hi, everybody. And today's topic, I think, is a fairly important topic. We're going to talk about security, and specifically as security applies into the Apache Kafka environment. And there are obviously some common themes that we're going to cover, but there's also some fairly Kafka-specific things that we're going to get into. So with that, let me start with kind of, I would say, a simple diagram that shows what today's kind of Kafka environments look like. So if we look at common or simple implementations of Kafka, you would see, a Kafka cluster, and you have applications like producers and consumers that basically exchange messages. So in a sense, you have producers sending messages to Kafka topics, and then you have consumers receiving those messages. It's a fairly simple model. Applications sending messages and applications consuming messages. So one would think that securing this environment should be a fairly simple task. And then we're going to get into some of the examples as to why this is actually a fairly challenging undertaking to secure this environment. So you've got a simple environment like this, and typically the main, I would say, building blocks of this, you have applications, you have brokers, you have messages. And those are the basic building blocks of this environment. Now, if we go a little further and we'll look at the Kafka cluster, we know today Kafka has been around for some time, has been adopted by many different organizations, and it's being adopted actually by a variety of different applications, especially for event streaming and sending small messages. So Kafka has been fairly robust, and few people actually report, I would say, significant problems with Kafka as a messaging platform. However, if we look at the different risk factors or attack, I call them sometimes attack vectors, you'd find that it's actually getting fairly complicated. So the first attack vector you can consider, we know that the Kafka clusters run in some kind of environment. So that would be infrastructure. So let's call it infrastructure. So that would be either running on-prem, or it could be in the cloud, running typically within either containers or VMs, and you have network and storage. So those are the basic building blocks of the infrastructure, and obviously that needs to be secured. So it's a very common kind of, I would say, a base layer of a risk vector that can impact the security of a cluster. So people usually focus on things like, firewalls and stuff like that. So that's, I would call it the basic infrastructure. The next attack vector and the risk vector is a fairly significant, and that is code. And what I mean by code is Apache Kafka is open source code. And obviously, depending what kind of Apache Kafka you use, there's other code could be on top of it, vendor-specific code. So what I mean by that is all of the open source code that comprises Kafka implementation itself. And as we know, there's a lot of vulnerabilities in there, and it's constantly being discovered. So code is actually one of the main attack vectors that could compromise Kafka security or could be exploited. The other risk vector, I call it producer consumers, are basically the application layer itself, which means anything touches Kafka in effect could introduce, I would say, an attack vector. So even if your Kafka cluster in this particular case is completely secured through the infrastructure, you have this attack vectors through code and producers and consumers, the applications that actually touch the Kafka cluster itself. And then the last category is usually I would put in a bucket what I would call other external tools, people, and processes. And if you look at the different ways that you secure a Kafka cluster, you would have to consider all of these, I would say, four main buckets. And that is infrastructure, how your infrastructure is secured, how your code is secured, or do you actually scan for vulnerabilities and things like that. Anything that has to do with applications that touch the Kafka cluster is going to have to be considered. And obviously anything on top of it that is exterior to the Kafka cluster, tools and people and processes, is going to have to be looked at as well. So I would consider that in order to really understand how to secure a Kafka cluster is going to have to be considered not just from the Kafka perspective itself, but also all of the external entities that touch or interact with the Kafka clusters. So let's deep dive into each one. So when we talk about specifically the infrastructure piece, and that's typically when people start deploying Kafka clusters, that's where they start, is the infrastructure. And that is, let's set up firewalls. Let's figure out what ports need to be open. We know that the Kafka cluster typically exposes GMX metrics for monitoring. How do you expose the different interfaces that are used by Kafka clusters and external tools? And then you have obviously the configuration and metadata, depending on if you're using, for example, Zookeeper. Well, how do you secure the metadata that's maintained? Now, in the newer versions, Zookeeper has gone away. But it's still, you have to consider how the different configuration metadata is secured. Access controls, firewalls, and if you deploy in the cloud infrastructure, obviously you're going to have to consider how the cloud infrastructure itself is secured. And then from there, each of these, because today most of the infrastructure is pretty much code, you're going to have to consider how you update this environment. I call it in a category called patches. So this environment is going to have to be constantly patched up to make sure that you're up to date on most current, I would say, security patches and vulnerabilities. However, it also, Kafka cluster exposes a whole bunch of metrics, logs, traces, and audit logs. So then the question becomes well, what do you do with these types of information that's actually being produced and exposed by the Kafka cluster? Keep in mind, and we're going to talk about it a little later, there's a lot of, I would say, security-like information that's provided in the logs. So you're going to have to think about how that's actually secured as well. And the main question becomes do you actually scan and audit your cluster? Because you could set it up in the infrastructure, and then, as you know, there's always drift and changes happen. You typically want to be able to audit your Kafka cluster periodically to make sure that you're still in line with your security policies. And then all of the metrics and logs and traces. Well, the question is, what do you do with that? Do you have an observability tooling that ingests these and then analyzes that, or is it just sitting in the logs? So as part of that security assessment, I would say, of the infrastructure, you would have to look at access control, firewalls, all the different ports that are being opened by Kafka and how they're being accessed, how your configured metadata is being secured and accessed. And then obviously anything that has to do with patches that are being applied has to be put in place. So even securing infrastructure is a fairly complex undertaking because there's just a lot of moving parts and a lot of attack vectors that could be used and compromise the Kafka cluster itself. So securing the infrastructure becomes an important aspect of in securing the Kafka cluster. So now code opens a completely new set of challenges, I think, for anybody who deploys Kafka cluster, but pretty much any open source any open source stack. So let's just look at this as an example. A Kafka, let's say a Kafka open source project. You could see, and in fact, if you kind of zero in on the commits, so obviously Kafka open source is being maintained by open source community, and there's a lot of different people contributing to this project. And usually you could just see that in the past 12 months, how many commits, and the commits and the number of commits is actually growing. In the past month, there was up 44% growth from the previous 12 months. So what that means is the rate of change is pretty high. And as you deploy your Kafka environment, and as you obviously upgrade from one version to another, you need to keep in mind that you're pulling in all of this open source and all of the dependencies into your environment, which means obviously any vulnerabilities that exist or any potential security problems that could exist in the code will be pulled into your environment and obviously can potentially expose you to risks. So what that means is typically is that you would need to scan your code for known vulnerabilities and obviously making sure that you update it. So keeping track of your versions across the clusters, making sure that they're consistent, and making sure that you constantly keep check of what are the vulnerabilities and keep the your versions up to date to make sure that you don't get hit with some known vulnerability you should have patched up, and suddenly your Kafka cluster becomes falls victim to a fairly known vulnerability. Obviously, it doesn't solve the problem of unknown vulnerabilities. We don't know what we don't know, but at least the things that we know, you should be able to scan your environment and apply those patches. And in fact, there's actually many services that show you kind of these vulnerabilities, so it should not be difficult undertaking to keep track of these. Now, what's interesting is just an interesting stat that even though there's vulnerabilities unknown in the open source, there's not really, there's a significant number of companies that do not really take this into account. And if we look at, in fact, the project vulnerability report for Apache Kafka, you would see that it's fairly good track record, but it still you still have a vulnerability coming from the code, and therefore you cannot completely discount it. So therefore it needs to be taken into account, and the environment needs to be scanned and updated. And it's still based on this review. I would say almost 30% of companies don't really apply these best practices. So going into the applications, and again, we'll find that the code is actually one of the very common themes, and it goes across the board. We talked about the infrastructure part, which is obviously today's mostly code, and that plays a big role. And we've talked about the code that for the Apache Kafka itself and all of the dependencies. But all of the applications, well, that's code as well. So applications like producers and consumers, they obviously interact with the Kafka cluster. And the question then becomes is there's a few things to consider. Well, one is how do you actually secure the code that is being used by the applications and making sure that you don't have vulnerabilities there. But on the other hand, you also have to consider things like how do you secure message traffic? And there are a couple of things there. Well, how do you maintain integrity of the messages? And what that means is as the message is sent from, let's say, producer to consumer, well, what happens if they get modified in the process? So obviously you want to implement things like encryption to make sure that the messages cannot be just intercepted, stolen in some way, or used in some kind of fashion, or could be completely modified. So encryption becomes an important aspect of this. And so I would usually propose to use an end-to-end encryption for application to application instead of completely built into the infrastructure. So application encrypts the message, sends, and the consumer decrypts the message. However, in this case, once you start introducing encryption, you obviously now start to think about, well, how are you going to manage, certificates? So that opens a whole other area of complexity. As you start layering the services, you start thinking about, well, for me to do proper encryption, I have to now introduce and manage certificates. So data integrity becomes a fairly significant undertaking, even though the model of just sending and receiving messages is fairly simple. So how do you manage your certificates? How do you ensure your data integrity? And obviously authentication and access control for the applications themselves. You don't want just producers or applications connecting to your cluster and just without any authentication or access control. So those things have to be obviously considered when you look at the security of your Kafka cluster. Now, obviously, there's also an area, I would say, on application IT, which is the application infrastructure itself. Again, applications run also within their own environment, very much like the Kafka cluster, and you want to make sure that that also follows some best practices, which is the same thing that we talked about for infrastructure, like applying patches and just make sure that you scan for vulnerabilities and firewalls and things like that have to be applied in the application IT infrastructure itself. But again, code becomes a common theme because we've had it through the infrastructure, through code for the open source, as well as for applications as well. And then the other, I would say, important aspect of securing the environment is the tooling. Now, so the tooling could really be anything that is external. There's different kinds of tools. Obviously, there's tooling for configuration management, there's observability and monitoring, and tooling introduces a whole set of new code that interfaces with your Kafka cluster. And your typical Kafka cluster will expose, again, metrics, log traces, as well as messages. You can also configure your Kafka cluster to output different logs, different kinds of logs. One of them is, for example, an audit log. These logs can usually, when this tooling is put in place, are being consumed by observability and monitoring tools and configuration management tools, and then obviously being used by people, and those people introduce different processes in place. So a common question, well, what kind of login do you have enabled? Do you have an audit trail? If so, what happens with that audit trail? What happens with these logs? Are they getting exposed? Are they getting consumed into the observability? And then what happens with that data that once it gets out of the out of the Kafka cluster? So the code again here plays a big role because code vulnerability. In fact, we've had situations where a monitoring there was a vulnerability in the monitoring software, which then introduced a potential backdoor into the monitored environment. So you want to make sure that you also pay attention to the different platforms and tools that are being deployed, and how they interface with the Kafka cluster itself. The other point to consider, I would say, is also in this particular case, obviously authentication and access control that the tooling has to the actual environment, because you don't want suddenly an attack vector coming in from the observability tooling and somehow disrupting the message flows at the bottom. And then the other part is, as the data is being exposed to the observability and other tools, how is this data being used? So if you, for example, look at logs, typical logs of, for example, Kafka, you will find host names, you will find applications, you will find IP addresses, you will find a host of very important data that, if exposed externally, could potentially compromise security of a cluster. Because if somebody gets a hold of these logs, again, this falls into the peoples and processes, then what happens is they can potentially use this information to forge an attack against your environment. And again, so just because you're securing this infrastructure, you're applying the patches, does not mean necessarily that you're completely secure, because the information that's being produced by the cluster and then exposed through various tools and through different processes and obviously folks that use this can potentially be used. So some of these I would again identify, I call them as leaks. That would fall into this category of I would say IP information, host, application, topology, even potential authentication data or some URLs. And again, that all of that information becomes really important. The other aspect to consider is that a lot of this tooling is also has bidirectional handshake with your Kafka environment. And what that means is the metrics are not just flowing up and just ended up in the cluster. A lot of the tooling that's currently in place has even though I didn't show it on this diagram, but has a bidirectional arrow in the sense, like, for example, a tooling could be for configuration, go and create, for example, a topic, or change some parameter of the topic, or some other attribute of a Kafka cluster. So obviously you want to make sure that you control that, and then that needs to be properly secured. So again, if your tooling is compromised, then what happens is now you open up an attack vector directly into your Kafka cluster. Again, important consideration in this environment. So in summary, before we kind of open to Q&A, I wanted to kind of summarize. So the Kafka cluster, even though I've seen a lot of people when they deploy Kafka clusters, they focus really on what's happening within the Kafka cluster itself. You know, how do you set up, you know, configurations? You know, how do you secure different topics and artifacts within Kafka, metadata, and firewalls and things like that. What I would say is consider the whole ecosystem, anything that touches your Kafka cluster. And that really opens the door then to things like code, IT, different tools, people, and processes, as well as different applications, producers, and consumers. Um, we know that the environment's never static; they're very dynamic. So you need to perform periodic code scans. And again, code is a very common theme through this, because all of this infrastructure today is code. Applications are code, open source, a high degree of change, and you're pulling that in. So you want to make sure that you constantly scan for vulnerabilities across all of the ecosystem, and obviously update this environment consistently. Look at your message traffic. Is all of the message traffic encrypted between brokers and applications? If there obviously any place where the messages are not encrypted, that opens a vulnerability. Messages could be tampered with, or they could be potentially stolen and used in some other fashion. Make sure your logging is turned on, especially audit trails. And these audit trails and metrics should be analyzed by, I would say, some kind of an observability tooling. We at meshIQ provide one that allows us to consume that information and make sense of that. So the audit trails need to be looked at and analyzed for possible security breaches. And then obviously with, you know, tools are tools, but at the end of the day, it's about people and processes. So you want to make sure that you have obviously well-trained folks that understand security, but also have the right processes in place so you can secure this environment. And that's how we went, even though the infrastructure is fairly simple. You know, how simpler can you get? You know, you send a message and then on the other hand receive it. But as we've seen here, it is a fairly complicated if you want to secure this environment and then keep up with securing this environment as this ecosystem evolves. So implement consistent security policies and make sure you have, you know, trained security folks that know, you know, how Kafka works, and then also all of the touch points across the Kafka cluster. And with that, I'd like to open for Q&A, so we can address some questions.
Yes, thank you, Albert. Yeah, I did receive a couple questions. The first one was, what strategy would you use for monitoring and auditing security events in Kafka cluster?
So for I did mention it a little bit earlier. So Kafka does produce logs, audit logs. However, it's not just the Kafka operating system, and other infrastructure pieces also produce audit logs. So the best recommendation is these logs need to be aggregated in one point and then analyzed, and then obviously proper alerts have to be set on as to be able to detect these conditions. But the first step, obviously, to make sure that you have it all collected and put in I would say, an observability platform. I think that's an important consideration. Obviously, there's another side of that, and again, I mentioned it a little bit, is you have to have the folks that are trained in security be able to identify security breaches. Now, some of that could be automated through algorithms, things like that. But again, you want to make sure that you have the right processes and people in place to be able to understand, how to detect and how to react to different security alerts.
Great. So you mentioned having an observability tool. So how can observability tools impact security if they only consume metrics?
So in my previous slide, actually go back here. So there is, I didn't show it, but there is a lot of the observability tools, even though they consume, they do have a level of control. So one way is that actions could be executed through these observability tools and change things in the environment. The other side is the leaks or that this observability could provide through leaking important information such as host IP and other topology infrastructure data that then could be used by hackers. So I would say leaks of information that and again how that information is secured, and then also if it's compromised, control could be passed down to the Kafka cluster. And obviously the other one is I mentioned is the code itself, meaning if there is a vulnerability in the tooling itself, then they could potentially be used to compromise the integrity of the Kafka cluster.
Awesome, thanks. There was one more that came through. How would you ensure data and message integrity?
So the data integrity is typically you would ensure it by encryption. So you would encrypt. Now, some also would do compression, but the main element is encrypting messages that flow through the Kafka cluster. So you would want an application before it sends a message, it's going to have to encrypt the message, use a private public key encryption. And then the consumer, once it receives a message, is going to have to decrypt the message. That way, if there's any tampering or anything happens, that would usually invalidate the message. The other side is proper access control so that you don't have, applications or other tools that trying to connect that don't connect or expose your environment to potential vulnerabilities. So I would say proper ACL control, and then access control, authentication, and then encryption are the two places. And obviously nothing beats, at the end of the day, you still need also process and people, but those are the basic building blocks: encryption, authentication, and access control.
Great. Well, thank you, Albert. I think if no one has any other questions, I'll go ahead and close this session. So thank you all who joined in today. We will have this Tech Talk available on demand, posted on the meshIQ website following this call at www.meshiq.com. We'd love to have you join us again, so please be on the lookout for our future webinars next year. So thank you, everyone, and have a great rest of your day.